Hello, let's try to understand how do we find number of real zeros from a given quadratic function, correct? Now, quadratic functions can be represented in standard form, for example, ax squared plus bx plus c, or in vertex form, a into x minus h squared plus q, or in factored form, right, x minus a times x minus b, correct? We have not really given you example of factored form here because number of factors will give you number of real solutions, correct? So I'm not discussing that case here, but I would have asked that question later, okay? Now, let's go back to question number 1. Question number 1 is, describe how would you determine the number of zeros from the equation of quadratic function in standard form, right? This is a very basic equation, ax squared plus bx plus c. And as you know, the solution of the equation is that x equals to minus b plus or minus square root b square minus 4ac over 2a, correct? Now this is general solution of any standard equation, excellent equation. For any given equation you can find the solution, correct? Factor you can't do for all equations, correct? But this is a good solutions. Now this, under the radical we have b square minus 4ac. This is called the discriminant. We normally write capital D for it, okay? It means b square minus 4ac. Now, if this b square minus 4ac is negative, then under the radical we have a negative number, and in the set of real numbers we really don't have any solution for square root of a negative number, right? It becomes an imaginary number, so not a real zero, correct? So that is the condition when we have no real solution, right? So let me write here in general what is my d, and d is actually speaking b square minus 4ac, right? So whenever I use the term d for discriminant, it will mean b square minus 4ac, correct? Now, if I have seen now, if d equals to negative, right? That means what? That means b square minus 4ac is less than 0. In that case, how many solutions do I have? None, right? So this is the condition for no solutions, right? We'll write none. But if we have d is positive, right? That means b square minus 4ac is greater than 0. In that case, this becomes positive, and for every positive number we have two solutions, right? Minus b plus minus that positive number divided by 2a, correct? So we have two solutions, correct? So we have here two solutions, correct? Now let's take the third condition where d is negative. Is that okay? If d is 0. We already considered negative, right? But d is 0. So that means b square minus 4ac equals to 0. Now if b square minus 4ac is 0, then this radical will be 0, and the solution is minus b by 2a, correct? And that is only one solution. Do you agree with me? So just one solution. So number of solutions from a given standard form of quadratic function, very simple. Just find the discriminant. If it is 0, one solution. If it is positive, two solutions. If it is negative, none solution in the domain of real numbers. Remember that, okay? That's it. And now let's move on to question number 2, correct? Question number 2 says, consider the function f(x) equals to a x minus h whole square plus q. Explain how the signs of a and q help you to find number of zeros, correct? Well, this is very interesting, and this is the vertex form, right? You know that. So let's look at it like this. Let's say this is our coordinate system, and let's say a is positive. So we are considering a is positive. Positive means graph is going to go up. Is it okay? A positive means graph going up, right? Now q we have to see. If q is also positive, that means q is here, and graph going up means no real solution, correct? But if q is negative, then 2, and if q is 0, then 1. Is it okay? Well, if q is 0, then it is in any case one solution. So let me write that as first. If q equals to 0, then this implies fx equals to a times x minus h whole square, right? And this leads to one solution. Is that okay? Correct, because the vertex is really on the x-axis, right? At h0, right? This vertex is where? Vertex is at h0, which is on x-axis. It may open upwards or downward. It doesn't matter. But there's only one solution, which is at h. Is it okay? So this is the case where h is, or q is 0, correct? Now, let's consider a is positive. If a is positive, we saw that if q is above the axis, then the graph will move upwards, no solution, right? If a is negative, then two solutions, correct? That means they are of opposite sign and they give two solutions, otherwise none. Okay, so if a is positive and q is positive, right? Q is positive. In that case, q is here, and so the graph goes up and no solution, right? But if q is negative, right? If q is negative, then q will be here and graph going up will give me two solutions. Do you see that? And for q positive, graph will be like this, no solution, right? So what we see here is, if a is positive and q is negative, two solutions. If both are same signs, no solution. Now let's consider another example where we will take a as negative, okay? Now let me draw it here. How does it matter? Let me draw here, right? A is negative. Negative means going downwards. Is that okay? Now for going downwards, if q is positive, then q is somewhere above in this first quadrant, right? Let's say here. Then if you go downwards, then you'll cut at two places. Important thing to note here is a and q are of different sign. In that case, you get two roots. And if they are same sign, then you get only none, no root, right? So the condition for two zeros is, so two real zeros, you will find when a and q are opposite signs. Is it okay? Does it make sense? Do you see negative and positive? Then q is here and going down, right? And no real solution. If a and q are same sign. Do you understand? Does it make sense? Yes, it does. So very important conclusion. Just at looking at the equation, you can figure out how many solutions will there be. Now here is a good question for you. Now try to read and do it yourself. I'm not going to give you a solution for this one, okay? State two different ways to determine number of zeros of a function fx equals to 3 x minus 1 whole square minus 7. Well, it seems to be simple. One way we have already discussed here. What is the value of a? A is 3, which is positive. What is the value of q? Q is negative 7, which is negative. That means both are of different signs, and because a is positive and q is negative, it's kind of this kind of a situation. So we can say like what? Think about it. It's not a difficult concept. At 1 we have minus 7. So at 1 my vertex is here and 3 means going up, and of course if I go up from here, then I cut at two places. So that is one way of saying it. So that's perfect. We say one way is this, that we have two zeros. Is it okay? So how many zeros do we have? We have two zeros, correct? Two zeros. Now you have to tell me second way of doing it. What is the second way of looking at it so that we get two zeros? And that's the real communication thinking problem. Stop the video here, think about it, and then move on, because I'm just going to give you the solution, okay? The solution is very simple. Let's assume that minus 7 is not there. In that case, the graph will be 3. This at 1 we will have a root, right? Like this, correct? This is without minus 7. Now if I add minus 7 to this, then what happens? this will move down, and if I move it down, then I'll definitely get two solutions. So this is another explanation of the same thing, that imagine this number is not there, then we have one solution. If this was positive, then we would have moved up, right? No solution. Do you understand? So that is the second way of explaining that we'll have two solutions for this particular equation. I hope you understand and enjoy this particular video.